Hello all you sorry excuses for math students, it's Dwarf8 here, aka the best calculuser in all of YouTube. That's right, there is no one better at me in calculus, and if you question that, you've either eaten solidified horse poo when you were little, or you're actually smart, because you know I'm being sarcastic right now beyond belief, and throughout the whole video, even though most of you probably just skipped this long boring introduction to get to the math. But anyway, my goal, other than to show off my amazing skills and potential hubris, is to educate you, so that you may one day be the mad scientist that makes nuclear bombs and explodes the entire city of London, so that America may be one day safe from Saudi Englishmen that threaten our very existence. So without further ado, let's get started. I will be doing random derivatives throughout this video, and if you would like extra help with certain aspects of derivatives because you're too lame to ask your teacher or you just like to make me work, let me know in the comments below. Don't be afraid to pause, because I too like to admire the handiwork of a famed genius such as myself. Right off the bat, I want to separate the terms in this equation because I like making things easy for myself. I noticed the e and the natural log at the top, so being a clearly superior student, I can recognize that things will cancel out due to log rules. I just glanced for ways to simplify because I'm so OG like that, so I take the 2 on the x squared and I put it in front of the ln x because I can. Then I notice that there are 2 ln x's, so I can just turn into e to the ln x plus ln of x and break it up into 2 ln of x's. Now I can finally cancel out the e to the ln's and just leave x's. There are 2 x's and it just becomes x squared, and the equation, so shocked at my amazing simplifying skills, cried so hard that it moved back into its mother function's home, where it could live in hiding and not have to cry so much. With my totally awesome and, dare I say, transcendent skills, recognizing things just becomes second nature for me, so I suggest that you all learn to do this quickly, or you will drown in a pit full of mutated keys that will grab onto your groins and make you scream like a girl. So now that the equation is not a pain in my inner thighs, I go to use power rule on both terms, putting the exponents in front, then subtracting 1 from the exponents, and I get my answer. For this next one, I see some trig, but no worries, because my unparalleled skills will make this problem seem like a cheap Professor Layton puzzle. I notice that there are y's where there shouldn't be, so I'm dealing with an implicit equation here. So I go on and do product rule. If you are worse than me in calculus, which I would imagine most of you who watch this video are, yes, I meant that to be offensive, I suggest separating your work with lines, barriers, bow ties, your own spit, peanut butter, your own spit mixed with peanut butter, anything, so that you wouldn't be confused. The derivative of x is just 1, so I just leave cosine y alone. I know that the derivative of cosine is negative sign, so I have to attach a minus sign instead of a plus sign in front. I leave the x alone, put sine y, but because we're trying to find the derivative with respect to x and not y, we have to think of y as a chain rule function and attach the derivative of y with respect to x. I apply the same stupidly easy principles to the next term, making sure that I don't exclude y entirely and use dy over dx. The derivative of a constant is always 0, so that's easy. Now I gotta rearrange things so that my dy over dx's are married. This is a legally homosexual country, so something like that is socially accepted now, don't worry. I have to factor out the dy over dx and divide both sides so that I completely isolate dy over dx. Think of it as your health class. If you have 2 things that are attracted to each other, namely the dy over dx, they engage in intercourse and poop out a baby in front. A baby dy over dx. And I finally have my answer right here. Having fun yet? Well, if you aren't, then you obviously are not narwhals because you are not so awesome. Looks like we have another implicit equation, but being the superior calculuser that I am, I know to keep in mind that I'm trying to find the derivative with respect to x. So I go ahead and do some quotient rule, remembering on the bottom that I need to FOIL. The right side is simple power rule with canceling a constant. I need to get the dy over dx onto one side, so I multiply both sides by this bottom function down here. I do some further isolation and I factor out the dy over dx, and it turns out that the writer of this equation was a giant pansy because you just get x in the end. Dividing both sides by x, you get the answer. Moving on to the last one here, I see pi, but because I know everything there is to know about math at the calculus BC level, as I am just naturally gifted, I know that pi is a constant. Sometimes I wish that pi were constant in real life because then I'd have an unlimited amount of it, and I could get all fat and diabetic. But anyway, moving on. Because pi is a constant, I can just ignore it completely, because I know that the derivative of a constant is just 0. Now I see some product rules, so I do x squared's derivative first, and leave 2 to the x alone. I leave x squared alone for the next term, and have 2 to the x ln 2 as the derivative. Now if you want to simplify it so you have 2 to the x plus 1, you can, but similar to the plot in the hentai anime, it doesn't matter. Now lastly, I will cover how you derive cosecant, secant, and cotangent just for funsies and because I take pleasure in doing math. For those of you noobs out there, these three are just reciprocals of sine, cosine, and tangent respectively. So I go with cosecant first, and I notice that the function looks like 1 over x, and I know that the derivative of that is negative 1 over x squared, with sine x plugged in for x. However, I have a bit of pesky chain rule going on, so I have to multiply the function by the derivative of x sine x, which is just cosine x. I split the function up into cosine x over sine x and 1 over sine x, which leaves me with negative cotangent x, cosecant of x. For secant of x, I know that it is just 1 over cosine x, and I use the same principles as the first problem and get negative 1 over cosine squared x. However, I do see some chain rule going on, like always, and the negative from the derivative of cosine x just makes the term positive. We split things up and get sine x over cosine x and 1 over cosine x, which ultimately becomes tan x secant x. For cotangent of x, I feel that quotient rule is appropriate here, and I'm too lazy to go over the individual parts, so I have to assume that you all are at least somewhat competent to do things yourself. Ultimately, you notice that we have just a giant trig identity, the easiest trig identity in the book I have to mention, and it just becomes negative 1 on top. 1 over sine squared x just becomes cosecant squared x, and I leave the negative and get the answer. So thank you all for watching. I know that you needed time to awe and glorify my honorable skills, so don't be afraid to go back and pause if you didn't get anything. This was just an introduction to the future multitude of videos I will cover. Once again, ladies and gentlemen, let me know in the comments what specific topics or types of problems you'd like covered more in depth, and I will pull out as many examples as I can and do them all for you on video. This is Dwarf Due Date, chilling with the homies.